In this video, we shall be looking at the turning point application of differentiation. In our previous video, we explained that if you have a curve in this form, that this point is the maximum and this point is the minimum. And the gradient dy dx at both maximum and minimum is equal to 0. You can see the video for better understanding. Don't forget to subscribe to this channel for more updates. To find the value of x at which the curve attains the maximum and minimum, we have to take the second derivative of the function. If I have this curve, and here is minimum, this is maximum. What implies that at maximum, the squared y dx squared should be less than 0, and the square y dx squared for minimum is greater than 0. Consider this example. If you have a function y is equal to x cubed minus x, you can be asked to find the value of x at which the function has the minimum value. Find the value of x at which the function has a minimum value. To solve this, we already know that at minimum or the maximum, the gradient dy dx is equal to 0. So differentiating this expression, the y dx is equal to, if I differentiate x cubed, it will be 3x squared minus, if I differentiate x, that will be 1. This is equal to 0. 3x squared minus 1 is equal to 0. And solving for x squared, 3x squared is equal to 1, and x squared is equal to 1 divided by 3. X is plus or minus square root of 1 divided by 3. This implies that x can take the value of plus square root of 1 divided by 3 or minus square root of 1 divided by 3. It is better for us to simplify this further and rationalize. We know that the square root of 1 is 1 plus or minus 1 divided by the square root of 3. So if I decide to rationalize this, this will be equal to plus or minus 1 divided by root 3 multiplied by root 3 divided by root 3. And this will be equal to plus or minus root 3 divided by 3. This implies that x can either be plus root 3 divided by 3 or minus root 3 divided by 3. But the question is, how do we know the value of x which is minimum? Should it be square root of 3 divided by 3 or minus square root of 3 divided by 3? Going back to our guide, we have that the square y dx square for minimum should be greater than 0. If the square y dx square is greater than 0, then we can say that value of x is minimum. So let's solve for the square y dx square. We already have the y dx to be equal to 3x minus 1, and the square y dx square will be equal to, this is 3x squared, please. The square y divided by the x squared, that would be, differentiation of this further will be 6x, and differentiation of a constant is 0. And since we have the value of x to be equal either 3 divided by 3 or minus root 3 divided by 3, so we have to substitute the value of x in this expression. So when x is equal to root 3 divided by 3, this will be equal to, this is 6x. If I substitute x to be this value, this will be 6 root 3 divided by 3, and this will be equal to 1, and 3 cancel itself, that will be equal to 2 root 3. And if I substitute when x is equal to minus root 3 divided by 3, we have 6x. If I substitute minus 3 multiplied by minus root 3 divided by 3, and this will be equal to minus 2 root 3. But remember, the square y dx square for minimum should be greater than 0. So at this point, if we check the square y dx square, which one is greater than 0? This is greater than 0. Therefore, the value of x at minimum is x is equal to square root 3 divided by 3. Consider this example. X cubed minus 2x squared minus 4x, x cubed plus 2x squared minus 4x plus 7. We are asked to find the value of x at which the function attained maximum. So to solve this, we already know that the y dx at both maximum and minimum, the gradient is 0. So if I differentiate this, then I have that the y dx is equal to, differentiation of x cubed will be 3x squared plus differentiation of this 2x is 4x minus 4, differentiation of a constant is 0, and this is equal to 0. 3x squared plus 4x minus 4 is equal to 0. We can solve this using factorization method. The coefficient of x squared here is 3, and 3 multiplied by minus 4 will be minus 12, and the middle value is 4. Therefore, we have to look for two numbers at which, when they multiply each other, it will give us minus 12, and if we add it, it will be 4. I think it should be 6, 2, and minus 2. Minus 2 multiplied by this will be minus 12, and minus 2 plus 6 will be 4. Therefore, this is 3x squared minus 2x plus 6x minus 4 is equal to 0 plus. Then if I decide to factor out x, I'll be left with 3x minus 2. If I decide to factor 2 here, this will be 3x minus 2 equal to 0. Therefore, I have my factors to be x plus 2 and 3x minus 2, and both are equal to 0. Therefore, the value of x plus 2 is equal to 0, or 3x minus 2 is equal to 0. For x plus 2, x here is minus 2, or this should be equal to 2 divided by 3. We have to solve further to determine the point at which it attained maximum. Therefore, maximum value, the square y, the x square, is less than 0. Therefore, we have to solve for the square y, the x square. We already have dy dx to be equal to 3x squared plus 4x minus 4. Therefore, the square y dx square will be equal to the differentiation of this will be 6x plus the differentiation of this will be 4, and differentiation of a constant is 0. Substituting the value of x in this expression, when x equal to 2 divided by 3, then I have this to be 6 multiplied by 2 divided by 3 plus 4, and this will be equal to 2. This divided by this is 1, this is 3 rather. Okay, it's 2 multiplied by 2 plus 4, and 2 multiplied by 2 is 4 plus 4, and this will be equal to 8. And when x is equal to minus 2, then we have 6 multiplied by minus 2 plus 4. And 6 multiplied by minus 2 will be minus 12 plus 4. Minus 12 plus 4 will be equal to minus 8. At this point, we know that the square y dx square should be less than 0. So, and minus 2 at the point where x is minus 2, that's what gave us minus 8, which is less than 0. Therefore, the value of x at maximum should be equal to minus 2. Thank you for watching this video. If you have any question, feel free to email us at science-elearningacademy@gmail.com. And don't forget to subscribe to this channel for more updates. Thank you.